Alrighty. Let's see what we got. So we were talking about confidence intervals before. I think we only got through like that one example though. But we did this whole thing here. We came up with the margin of error, what the confidence interval was. Is that correct? All right, then how would you do it for number 16? What would you say? In a random sample of 192 college students, 129 had part-time jobs, find the margin of error for the 95% confidence interval used to estimate the population proportion. What would you say? Which one? Yeah, which one? That's what one prop Z interval is correct. What, number 16?
Oh, I'm thinking 17. X, no, hold on. X would have to be, no, N would have to be 190.
N is 192.
X would have to be 129.
Yep.
And the C level would have to be 0.95.
Right. So what do you get? Well, that's correct. What'd you say? Oh. Oh, for the margin of error, you said? 0.3125? No. How'd you get that? Yep. For the margin of error? What's P with the upward arrow? That's the estimated proportion. That's not what the asking you for. The estimated proportion is just this number divided by this number. It's asking you for the margin of error. Well, you just don't know how to read the answer. You didn't do anything wrong. Nobody can type it in the calculator. There's two numbers you have to type in. Then all you have to do is be able to read the answer. It's not P hat. P hat's not the answer. So what's the answer? Well, you tell me. You're supposed to be able to figure it out. And this is not supposed to be the hard part. 0.066.
Not yet.
Maybe I wrote the wrong thing here. What'd you say? 664? Yeah, that sounds fun. All right, now, I mean, all you have to do is type this into one prop z int, then you get this. Then you just have to know what margin of error means, and you should be able to do it. Question? 6.6%. But you should be able to tell me how to find margin of error based off of having the two sides of the confidence interval. Does that make sense? We did that the first day. We did that last time also. Question? Those should be the easiest questions you have. Does that make sense? All right. This one's just typing in the calculator. They have all the numbers here for you, so that's not really good. All right, this one, let's go over this then. This is something new. So they have something that's called minimum sample size estimation. This is pretty important because like in real, like if you were really going to do something with this stuff and you actually had to sample something, this is probably the first thing you would probably try to figure out. You probably want to know what the minimum sample size that would be necessary for a specific level of confidence and such that. So what we can do is, if we have this formula again, C is equal to X bar minus the mean divided by the standard deviation. And what minimum sample size estimation means is really they want us to solve for N. They want us to see what we can start saying about N. Because like at the beginning, how many people do I need to estimate, do I need to sample so that I'm going to be within, let's say, 1% of the real answer for the people that favor a particular candidate? Does that make sense? Do you have to ask 50 people? Do you have to ask 100 people? Do you have to ask 1,000 people? Does that make sense? Right? Obviously, if you ask more, you get a better answer. Is that correct? Question with that? So we know that one time when we solve for z, if x is normally distributed, x bar is normally distributed with mean mu and standard deviation sigma over square root of n, and this would be the z-score. Does that make sense? If p hat, we said last time, was going to be normally distributed with mean p hat, we were going to say all square root of p hat q hat over n. So then if we were going to calculate z-score for this, z is going to equal to, well, p hat minus, or the estimated value, minus the true value, all over the square root of square root of whatever the true proportion would be times q. Does that make sense? This is the standard deviation. That's the mean. We put the mean there, right? We put the standard deviation on the bottom. Is that correct? How many standard deviations this is away from the mean? Does that make sense? So then, but the difference between these two things right here is sort of like the error. Because if your estimated proportion was 44%, and then the true proportion of people that favored the candidate was like 40%, you'd be off by 4%. Is that correct? If you said that the average amount of money people had was $100 and they ended up having really on average $80, right? Then your sample's off by $20. Is that correct? That's quite possible, right? But that's what we're always talking about when we say the margin of error. Does that make sense? There's some value we think is the estimated value. And then we're going to add or subtract the margin of error. This is p hat plus the margin of error and p hat minus the margin of error. Does that make sense? And then we think p is somewhere in here somewhere. Is that right? Right? So then p hat minus p, if p is in here somewhere, the biggest it could possibly be is e. Is that right? Does that make sense? So instead of writing this way, because this is kind of confusing with all of this stuff, why don't we just call that E, because the biggest that could possibly be is really what the margin of error is. Is that right? So then this is E over that, I guess, whatever. Right? Now, again, we really don't know what P is, so we're going to estimate what P is by using P hat and Q hat. Okay? We never actually know what P is, right? Does that make sense? All right, now I got to solve for N here, okay? So this thing is dividing by this fraction. If you divide by a fraction, you have to like flip it over. Does that make sense? So this, if we flip this over, this square root of n is going to go to the top. Does that make sense? But then this thing here can be rewritten as the square root of this over square root of this. So now this square root of n is going to go to the top. Does that make sense? Now I just solve for n. So I got to get the n by itself. So then square root of n, if I multiply this by sigma over e, and then multiply this by sigma over e. This thing will cancel, this thing will cancel, that thing will cancel. Then we get z times sigma over e. Does that make sense? And then here, we can do more or less the same thing. Multiply by root p hat q hat over e. Then this stuff cancels, that stuff cancels. Then you would end up with square root of n is equal to whatever this says, z times square root of p hat q hat over e. Okay? Now my thing stopped working, so I have to restart it. Okay. Now I got to solve for n. How do you solve for n now? So you got to get rid of the square root. You got to square both sides. So that means n is going to equal to z squared times sigma squared all over e squared in this case, right? And then in this case, n is going to equal to z squared times p hat q hat over e squared. Does that make sense? When you square the square root, the square root just goes away. Does that make sense? So then there are these two formulas. This is really the most algebra you will have to do in the entire class. Does that make sense? And then this is, they say what this is the sample size that would be necessary for a particular margin of error and a particular level of confidence. Because Z is going to be related to the level of confidence. Is that correct? Right, we talked about that before. Like if you're more confident, then Z is going to be further away, right? Does that make sense? So then this will get even larger if you want to be more confident. Does that make sense? If E goes up, does N go up? Sorry? Why? Yeah. Well, I don't like the way you're saying it. You're right that it goes down, but why? If you divide by a bigger number, right? Like if E was 100 versus E being like 10 or something, right? You would divide by an even bigger number. This would have to get smaller. Does that make sense? Because if you're allowing more error, right? Should have to sample less. Does that make sense? Does that make sense? If you're going to be more confident, though, Z is going to be bigger, right? You would have to sample more. Does that make sense? Does that make sense? All right, but there's one other thing with this that you have to pay attention to also. So when calculating these things, a lot of times this will end up giving you a decimal. Does that make sense? If it gives you a decimal, though, and I say to you like N is 6.71 or something, what would that mean? What would you have to do then? If the result of the calculation ended up being 6.71, let's say 6.17 actually, 6.17. What does this mean? So if I say the minimum sample size calculation is this particular thing, and let's pretend I solved this correctly, right? And then let's say you knew what Z was, and you knew what sigma was, and you knew what E was, whatever, which we're going to do it in a second. And just to say the answer ended up being this number. What does that mean? So you're going to sample 6.17 people? No, I'm just saying, like, well, how are you going to, what does that mean? Can't sample 6.17 people, right? So what are you going to do? If I say 6.17 is the minimum sample size that's required for a particular level of confidence, for a particular margin of error, you would have to sample at least 7 people. Does that make sense? Does that make sense? Somebody explain your own words in another situation, not according to statistics or something like that. Yeah, why am I not rounding? Why don't I round down to 6? Yeah, but why don't I just round down? Why don't I just round down though? To 6. 6 is closer to 6.17 than 7 is, right? Why don't I just do that? Sorry, yeah, I want you to say it in like your own words, like using the same numbers, but just you don't have to talk about statistics. You can talk about any situation. Does that make sense? Uh, yeah. I'm just thinking like you go to a store and the thing costs $6.17, and you have $6 bills and you have $7 bills. You're not buying the damn thing unless you have $7. Does that make sense? Whether you got a credit card or not, even if you got a credit card, you only got $6 on your credit card. You ain't buying it that way either. You get rejected. I mean, they'll stop you. So oh, wait till you got to pay rent.
Don't tell me you got that much in your car right now as we speak. Stop right now.
What are you talking?
No, you said like.
Yeah, because wait, I'm telling you, like I remember all these people they talk all this nonsense, and then they would sit there and they actually have to pay for their place where they have to live and stuff like that. And then all of a sudden, their credit cards are practically maxed out, and yeah, they would have. Actually, I know a lot of people that have way less than $6 available on their credit cards. They have negative dollars available on their credit cards because they end up charging more than they can actually spend and stuff like that. So then it actually keeps increasing. All right, but this should make sense, I believe. Is that right? Okay. So this is use the given data to find the minimum sample size required to estimate the population proportion, margin of error, this thing, confidence level, whatever, P hat, Q hat, unknown. So then the formula was E is equal to Z squared over, or excuse me, E is equal to, N is equal to Z squared over E squared times, then it was square root of P hat, Q hat. That was the formula. All right, let's do the second one first. It's almost the same question. All right, how do I figure out what Z is? What how do I do this? What do I plug in here? How do you do it? Whoops. 19 actually.
Okay.
What do you think? If you have this formula, what would you guess? Which one has to be the margin of error? E, right? Does that make sense? Yeah. Point 0.04 squared for the bottom for sure. That's correct. Nope. Nope. How do you figure out the Z? We just talked about it a couple seconds ago. How do you figure out Z? Sorry? What? What does Z mean? Rounding up what by one? What are you even talking about? What does Z mean? Standard of deviations is correct. So which part here has to do with something about the standard deviations? There's only like a couple things they said there. Margin of error does, that's true. But it's this number of standard deviations times the standard deviation, right? But what tells us the number of standard deviations? The confidence level. Oh, you can't just ignore that, right? If you're more confident, right? Gonna be more standard deviations. Does that make sense? Does that make sense? Right? If you're less confident, then you would use less standard deviations. Is that correct? Does that make sense, guys? So how do we use the confidence level to get the answer? No, you already said that 0.04 is this part squared, right? P hat is obvious. They told you what P hat is. It's 0.12, right? Q hat, you should be able to tell me you know what that is. Is that correct? What is it then? So what is it? 88%, right? If this is 12, the other one's 88. Is that correct? So the only thing you have to be able to tell me how to do here is Z, right? And Z, we just said is related to the confidence level, right? Because if you're more confident, you have to be more standard deviations away. Is that right? So remember, this is really this critical Z-score necessary for the particular confidence level, right? So I could write it as what we were writing before, Z alpha over 2. Z alpha over 2. Does that make sense? So how do we find that? We talked about that before. Is that right? What is alpha in this case? If they say 99%, what is alpha? What? Oh. What did we say alpha was before? You guys gotta pay attention. It's not. We said what alpha meant. We talked about it a bunch of times. I'm talking about what we said in this class. No. What? What does alpha mean? Come on. Nobody knows again. I can just finish all the stuff. I don't see what's going on here. Like, I can just finish it. I'm asking you questions because you're supposed to pay attention. You don't want to pay attention, I'll just finish it. What did we say alpha was? Yeah, what did that mean? What did we say when we write alpha over 2 here? What does that mean? What did we say when we write Z alpha like this? What did that mean? We just went through this last class again. This was on your exam. Like, I don't know what you expect. Do you want to pass this class? Because maybe it's a good idea to learn the things I'm saying. Maybe. Just maybe. Like, if I scroll up right here and go up and show you that that's exactly what we were writing before last class, right? And it's here. Is that right? It's all of this. We did all of this. Is that correct? I said that there were particular numbers that were even helpful to remember. 1.96. Is that right? We did it more than once. This wasn't even from this section. This was from chapter 6. This is chapter 7, right? What did the alpha mean here again? This was the area to the right. Is that correct? So then this means this is the area to the right. They're just calling it alpha over 2. Does that make sense? Why are they dividing by 2 again? That part's a little confusing, to be honest. Why are they dividing by 2? Does anybody remember? Why do we have to divide by 2? Oh, and there's another thing I don't like that I could tell that this means you don't really understand. I don't see a single one of you writing down a picture to try to do this. Now, one of you, I drew a curve before, but you're not drawing it. What should you be drawing? Yep, normal distribution. With what though? What do I label? But the only thing I've asked you about so far is the confidence level. All we have to do is say, what does the confidence level have to do with Z? What does the confidence level have to do with the picture? How do you label the picture with respect to a 99% confidence level? No. .5%. Yeah, but not 0.5, right? Okay. No, point like there's 99% in the middle. Right? Because we said we had to go a certain amount in this direction, a certain amount in the other direction. Is that correct? 0.5%. So this is 0.005. Is that correct? That's why I kept saying not 0.5. You can't tell me it's 0.5. 0.5 is half the whole graph. 0.5% or 0.005. It's like a half of a penny. Does that make sense? Right? The whole thing's $1. This is 99 cents. It's got to be a penny total. It was a half of a penny. Is that correct? Right? What did alpha mean though? What did we say alpha was? We said alpha was the parts over here and over here. We said that was what we called the alpha region. Does that make sense? Then each one of them would be alpha over 2 if it's symmetric. Is that correct? Does that make sense? I'm not going to keep going over this stuff over and over again, guys. I'm really not. Some of you are really not paying attention at all, and that's not my problem. Does that make sense? Okay. Question with this? We also said that, I know I wrote this down, I can just scroll up to show you if you really want me to show you. But we said that 1 minus alpha, I called that the confidence level. So this is equal to 99%, right? So that means alpha is 1%, right? Is that correct? Is that correct? Does that make sense, Chloe? Does that make sense, guys? This is 1%. Is that right? So then alpha over 2 is half of that. That much. Is that right? But it's instead of doing all this algebra and stuff like that, you should just be drawing the picture. All I said was this is 99%, and that's 1, those over there divided by 2. Is that correct? I don't think that's very difficult. Does that make sense? But you still haven't answered the question. How do I use this to start saying what Z needs to be? I mean, there's definitely a position here and a position here, which is a certain number of standard deviations away from the mean. Is that right? So how do we find the right number? No, that's not a Z, that's an area. Right? This is like a probability or something. Is that correct? It's not a Z score. Is that right? This is on your test, the one you're just supposed to take. It's in the chapter 6. It's on your homework too. You even asked me this question when you came Tuesday. How do you find the number of standard deviations for this position or for this position? We did this again last class. We wrote it out all again. I remember we did it. I could show you in 1 second, but I'm not giving you the answer now until you tell me how to do it. There's only 2 stupid functions to learn how to use: normal CDF and invnorm. Which one is it? Wow. So what do? Add up the area to the left. All you have to do is add this number and this number. So it's 0.995. We literally just did this. Where is this? Right here. We did all of this again last class. Is that correct? We had done it when we did invnorm. Is that right? And then we did these examples here. We did it with 98%. We did it with 93%. Is that correct? This was on your test. This is in your homework. I'm telling you, you have to know this stuff. There's no way you can pass the final if you don't know these things. No way. Does that understand what I'm saying? If there's 2 functions you have to learn how to use for the entire chapter, for chapter 6, you have to tell me you know how to do those. Question? Now, if you tell me you don't remember what some of these things mean, that's fine. Because this is really actually kind of new. Does that make sense? But once I start drawing this, and I start asking you what Z is, you have to be able to tell me. Does that make sense? Does that make sense? Before you've drawn all this stuff, fine. I think you don't necessarily have to know how to do it. Does that make sense? Because you still haven't figured it out yet. All right. But once I have this here, no. There's multiple questions on your test about this. Does that make sense? Question? So then this means, what do I write for all these things then? Z is just inv norm of, what was it? Point. That's correct. This is squared. This is 0.04 squared. What did we say? P hat was what? 0.12, right? Q hat is 0.88 is correct. Does that make sense? What do you get when you do that? Because this is another place I start seeing people make mistakes because they don't type in the calculator correctly. You got to make sure you follow order of operations. Does that make sense? Inverse norm of whatever this is, right? You could just do that first and separate it. You don't have to write it these like all like this, right? What do you get? Come on. You gotta make sure you practice typing these things in now. Otherwise, I see people make a lot of mistakes. Okay? Sigma sign? There's no, yeah, but you don't, there's nothing here. All you gotta do is just do this. Did you get an answer? Yeah. All right, now, the only thing is though that like there should be absolutely no reason why you guys cannot type it into the calculator. This part should be easy once we've drawn the picture, because that part you're supposed to know how to do. Does that make sense? This has to be easy. Don't tell me you can't type it in the calculator, okay? Watch how easy it is. And this just means you haven't typed in it enough. Does that make sense? Because you type it in a little bit, you're going to tell me it's fine. All right? Because when I go into InvNorm here, right? You got to do 0.995, right? Now, again, I'd rather delete all this stuff just because it's like too much crap. But you could just push enter. There's the number. Does that make sense? Right? Then just go back to it, push enter again. Does that make sense? Square it, right? There's even a button there for you, right? That's not hard. That's not hard. Does that make sense? Then we still have to multiply by the square root thing. But if you get confused, let's say you're a little confused, you're not sure how to type all of these things in, do them in parts. It leaves it there for you. Does that make sense? Like just go here, click this one, square it, leave it there. Does that make sense? Right? I should not have to tell you this. Does that make sense? 0.04, if you think that you don't want to write it all together, leave that there. We could divide it afterwards. Does that make sense? Right? Do the square root separately also. I mean, you can have them there. Does that make sense? Then what is it? It's going to be what? This one times this one divided by this one because it's on the bottom. Does that make sense? And it'll give you the same thing. Does that make sense? But you can see it. How do you mess it up then? Does that make sense? Reverse what I'm saying? So what's the answer? No. What did we say before? What's the answer? $1,348. Why? Because you got to round up, right? Does that make sense? Normal distribution is symmetric, yeah. We don't do it in this class. We really should, but they took it out. But like, so it's a good question though, okay? But they so sometimes we start talking about like the distribution of standard deviations. Because like if I say there's a group over there and there's a group over there, it's hard for me to actually figure out what their averages are and whether their averages are actually going to be the same. Sometimes what's actually easier is we can see how much variation there is in the groups. And if we start saying the two groups are supposed to be the same thing, they should really have the same type of variation also. Does that make sense? So if you start comparing the variations to each other, then we start just talking about the distribution of sample variances or sample standard deviations, either one, right? So if I start talking about averages, you can start saying that the average is going to be like negative or average is going to be positive. Does that make sense? Right? But standard deviation has to be only positive. Does that make sense? So it's like if you have had this stuff over here, it kind of can't be over here anymore. Does that make sense? So then there's like a distribution that they call chi-squared, which again we used to talk about in this class, but we don't do it anymore. But this is saying that like, so there's a certain probability of getting some sort of standard deviation or something like that, and then it's like very hard to get ones that are like very, 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 very large. Does that make sense? Does that make sense? All right. But this distribution, if I started trying to construct a confidence interval then, all right, like maybe like 5% is like right there, but then 5% over here is like there or something. Does that make sense? And then maybe the mean is right there. Okay. So then the amount you have to go this way and then the amount you have to go this way, it's not the same now. All right. But the way you end up doing it on the calculator is actually so similar, it's not even funny. All right. So actually, this is a good way we can still say how to do this or teach the same thing. Does that make sense? So like if I go on the calculator, let me just see if this thing has it. It doesn't have it. Okay. But all right, this one. This thing, I don't know if you remember what it says for InvNorm, but InvNorm said previously it was like we had to tell it some area, right? Then there was like a mean and standard deviation. Is that correct? We haven't talked about degrees of freedom, but we're gonna actually talk about it in like 2 seconds. All right. And this P is an area. Does that make sense? All right. So like if I type in to this function, okay? Usually to find this position right here, we would be doing like InvNorm, right? But this is not a normal distribution. So we end up doing this thing called inv chi-square, okay? This is chi-squared. Does that make sense? Then what do you have to type in here? Oh, guess what this stupid thing, oops. Guess what this P means? Area to the left. Does that make sense? Does that make sense? So what area would you have to type in to figure it out for this position right here? No. What's the area to the left of this? 0.95. Does that make sense? Then there's some more stuff you have to type in here because there's some things you have to tell it about the individual chi-square distribution, just like we always have to tell the normal distribution what the mean is, what the standard deviation is. Does that make sense? Does that make sense? Okay, but this would give you the answer. Does that make sense? What about for this one here? What would you have to type in there? You have to do inverse chi-square of what? What would you have to type in? Sorry? 0.05. Because the area to the left. Does that make sense? And then it'll spit out the answers. Does that make sense? So I'm just gonna do it real quick just to show you. All right. So this was Q chi-square, and then I don't know. Let's do point. What did he say? Let's do 95% confidence. So this is like 0.025. And then N, I'm just gonna make it 2 or something, or 1, whatever. And then we'll do it again, and I'll do it for 0.995. Oops, I didn't want to do 0.995. That was stupid. 0.975, excuse me. So if I do this thing here for this particular distribution, it's saying like very, 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 very close to the beginning of the graph would be the first position. And then 5 units in the other direction would be the other position. So like, for instance, something like right there and something like right there. Does that make sense? Does that make sense? Do you understand what I mean though with this inverse thing? This expects area. Does that make sense? All right, for this one. First, tell me how to find Z alpha over 2 first for this one. $18. Because they told me what E is, so that part's easy. Is that right? There's P hat, Q hat part, we don't know how to do yet, but we'll talk about that. But what about the, what do we do for Z? That part we should know how to do. We just talked about it. No, to the left. To the left. See, I told you Beyonce would help. I told you. Inv norm 0.98 is correct. Good. That's true. All right, so that's good. Okay. Now, what would you have to write for P hat and Q hat? Okay, this part I haven't explained yet, though. All right. Now, P hat and Q hat are unknown. Does that make sense? All right. So there's a couple of ways we can think about this. All right. The formula here over here has this is whatever this is. This is P hat times Q hat, right? That part. So let's just start talking about P hat times Q hat a little bit. Okay. If we don't know anything about what P and Q are, right? Then we should have to sample the most amount of people. Does that make sense? We're so confused we don't even know what P hat and Q hat are. Is that correct? N should be as large as possible. Is that right? So like P hat, Q hat. Like if P hat is 0 and Q is 1, that's not very big. You get 0. Is that correct? If this thing is 1 and that thing is 0, that's not very big. You get 0. Is that right? It turns out this becomes biggest when you do 0.5 times 0.5 and you get 0.25. Does that make sense? Because if I do like, I don't know, 1/4 times 3/4, this is 3/16. 3/16 is, I don't know, like 0.15 or something like that. I think it's like 0.15625 or something. I don't know. 0.81875. Okay. But Not bigger than this. Does that make sense? All right. So first of all, if P hat and Q hat are unknown, assume P hat is equal to 0.5 and Q hat is equal to 0.5. Does that make sense? All right, let's try and do another example though, just to explain why we would do this. Okay. All right, let's say we're going to play a game, but I'm not going to learn how to play and you're not going to learn how to play. But we're going to play. I don't know. I'm just going to start playing. Does that make sense? But we're not going to learn how to play. Does that make sense? So I don't know the rules. You don't know the rules, right? Who's going to win? No, I'm going to win, damn it. No, I'm just kidding. So like no, but who's gonna win? I don't freaking know. Nobody really should win more often. We both don't know how to play. We don't even seem like we care. Does that make sense? Right? You're gonna have just as good a chance of winning or bad chance as I would. Is that right? Does that make sense? Why are you calling me a cheater? I wonder. So then the anyway. All right. So but why so the thing is at that point, right, if we had no idea who really would win, right, then we would really have to guess that both of us really would have a 50% chance of winning. Is that correct? Is that right? That's all I really just said here. Is that right? Does that make sense? Another way you could say it is that this is the variance of a Bernoulli trial. We said previously, P times Q or P times 1 minus, excuse me, standard deviation. Standard deviation is the highest when it's 0.5 times 0.5. Because the reason is that if I start saying to you, right, people do it all the time, actually. You're like, what's the chance that that's going to happen? People are like, oh, 50%. Because they don't have any freaking idea how to calculate it. Does that make sense? They're just guessing. Oh, there's two chances, success and failure, 50%. But that's not really good. Does that make sense? Right? But if I start saying to you that, like, I think the chance of success is like 10%, the chance of failure is 90%. That means most of the time I'm saying I know what's going to happen. Is that right? Does that make sense? So when you start saying it's 50%, it really kind of means like you really have no idea. Does that make sense? Anytime they don't provide it, you have to assume the P hat and Q hat are 50%. Does that make sense? But you get why though? Because that'll make this the largest it could possibly be. Does that make sense? If this, because like if I don't, whoops. Let's just remember what we're trying to do here a little bit because this is kind of confusing. All right. So we're trying to estimate how many people we need to sample so that when we sample, we're going to be 96% confident that we're going to be within 0.005 of the correct answer. Does that make sense? Does that make sense? This means you're within 0.005. Is that right? Plus or minus? Does that make sense? So you're 96% confident you're going to be within 0.005. How many people do we need to sample? Do you understand why this is important? Does it make sense? This is really the first thing you do when you do statistics, this thing. Does that make sense? How many people do I need to sample, right? So then if I don't know anything about what P hat and Q hat are, I really don't know anything then, right? I have to make sure that I can sample the most amount of people possible. But I don't want to sample too much because I don't want to waste my time. Does that make sense? So what's the maximum this could possibly be for a particular level of confidence, for a particular margin of error? This thing would have to be maximized. Is that correct? If this thing's going to be maximized, it's 0.25 square rooted, which is just 0.5. Then you just end up multiplying here by 0.5. That's it. that make sense? In norm, what was this? 0.98 you said, right? Square this, divide this by, then it was like 0.005, I think. Squared, then I said multiply this by 0.5. That right? That was wrong. 0.005. I gotta check if this works. Yes, so. 84,358 people. Does that make sense? 358, sorry. What did I say? 354? What did I say? Dumb. 84, thank you. 358 is correct. Thank you. Does that make sense? Question with this? But you would expect, if you don't know what these things are, you would have to sample more people. Is that right? Does that make sense? What is this? I don't know, do the last one. Make the confidence interval. Confidence interval for the proportion of all such items that are defective. Hmm? No, read the question. It says construct the 98% confidence interval. Well, if you're saying you want to find the proportion of things that are defective, then you have to count the number that are defective, right? One prop Z interval is correct.
And what had to be 3.6. And the sea level had to be 4.8.
That's correct. So you just type that in, is that right? And then you just push calculate, and that's it. We're done. So then this is what? 0.0118 is less than P is less than 0.05757, I guess. Does that make sense? I really don't think it's easier, but there's not too many people in here that are actually typing it in and telling me the answer before he did. Like, I think it's pretty easy. Does that make sense? Good though. Okay. Question? Does everyone understand? All right, let's see what we got here. So now these should all be the same. Yeah, this one we did, right? Okay, now this is different, this stuff. Oh, so I gotta explain something. Okay, so now previously we kept talking about everything about like proportions in the previous section. Right? We said like P hat was like X over N or whatever. Is that right? I started saying P hat was distributed normally with mean P standard deviation square root of P hat Q hat over N, or that's what we would use because we don't have what P is, right? We said that the margin of error for this particular confidence interval was equal to Z alpha over 2 times square root of P hat Q hat over N, because this is the number of standard deviations times the standard deviation. Is that correct? Does that make sense to everybody? Number of standard deviations times standard deviation is margin of error, right? Does that make sense? All right. Then we started saying something about normal last time, and I was like, oh, well, X bar, right? Because like P hat really can be thought of as X bar. We can think of it in the same way, okay? But I don't want to go through all that algebra to do that necessarily, because it doesn't really help you on your exams and stuff like that. Does that make sense? But, or really to understand, to be honest, okay? But we did say though that X bar, when N is greater than 30, right? Just like this can only be used when N P hat and N Q hat were greater than or equal to 5. Does that make sense? When N is greater than 30, we can say that this is going to be normally distributed with some mean and some standard deviation if X is coming from a normal distribution, or X has a mean and X has a variance. Okay? Does that make sense? Then I started saying something like this. I was like, oh, well, then E is going to equal to Z alpha over 2 times whatever the standard deviation is, which would be this, I guess. And I even just started writing out a formula before about the minimum sample size about this stuff. Does that make sense? But there's like kind of a big problem with this. Because, so like in this case here, we were estimating, we were trying to make a confidence interval for P, right? Right? And we had to start using P hat and Q hat because we had nothing else to use to guess it. Is that correct? Right? But we didn't really need a second thing. We didn't need a standard deviation also. Does that make sense? All we needed was P hat. Once you get P hat, you automatically get Q hat. Is that right? Here, you would sort of need this and that if you really wanted to do Z-score or something. Does that make sense? Does that make sense? But if I say to you that in this case previously when we were doing confidence, a confidence interval, we're always trying to estimate a parameter, right? When we did this one, we were trying to estimate P. When we do this one, we're really trying to estimate mu. Does that make sense? But if we don't know what mu is, how the heck are we going to know what sigma is? Does that make sense? If mu is unknown, sigma is unknown because sigma is equal to the sum of xi minus mu squared, whatever, all divided by n square rooted. Does that make sense? You have to know what mu is. Does that make sense? Right? If we don't know this, we can't know that. Is that correct? So I'm not going to know this. Does that make sense? if sigma is unknown, Z or a normal distribution cannot be used because you can't actually calculate what Z is. You don't know what sigma is. Does that make sense? Right? Z is equal to what? X minus mu over sigma. Is that correct? Questions, sorry? Because I was saying, like, if we don't know any better, if nobody has any idea what the values actually are, the only fair thing to really do is to assume that P would be 0.5. And that was the example I was giving where I was saying, like, if we're going to play each other in a game, and then, like, if we really have no idea who's going to win, like, you should assume it's 50%, 50%, right? You shouldn't say, like, all of a sudden you're just going to win 90% of the time. Like, then you know something. Does that make sense? Right? So then, like, without saying anything better, right? If they're both unknown, you would assume they're 50%. Does that make sense? All right. So if sigma is unknown, Z or a normal distribution cannot be used. So this is when we start talking about this thing called, they make up another distribution. All right. We'll talk about it in a second. This one's very simple though. All right. For what we need to do. All right. All they say is that you don't know what this is. So you're going to have to start using S or the sample standard deviation, right? Because you don't know what sigma is. So you're going to use S to approximate it. Does that make sense? And then this part here, they start writing this thing T alpha over 2 instead. So then we start saying that X bar follows this thing called a T distribution with some mean, some standard deviation, and then this new thing, which is called degrees of freedom. What does this have to do with? So like the normal distribution is a 2-parameter distribution. The T distribution is a 3-parameter distribution. Not only do you need to know what the mean is, not only do you need to know what the standard deviation is, but you need to know also what n is. It actually changes based off of n. Okay? We'll see what this means in 1 second. It'll make a lot of sense. Okay? Questions so far, though? Bottom line, all that happens is they make up a whole new distribution. Does that make sense? Does that make sense? And usually, we almost never do this one because you almost never know what sigma is. But if they tell you what sigma is, then you can do Z. Does that make sense? So anytime in the questions, so then you have to start making a distinction also in the questions between if they're telling you this, the population standard deviation or the sample standard deviation. Does that make sense? We'll see in a second. Okay. Questions so far? Let's just talk about what this T distribution thing is a little bit. All right. Yeah, I just can't believe that the best place I can find something is Wikipedia all the time. It really is. For math, it's actually very good, surprisingly. What do you say? This thing? Wikipedia is very good for certain things. Some things is very bad for. Like if you do anything like political or stuff like that, it's garbage because then I can edit it, you can edit it, we can all change these things. But then when it comes to this like math stuff, like when you start editing it, people start getting so angry at you that they don't accept your edits. You know what I mean? There's too many people looking at it. Does that make sense? When it comes to these Republican Democrat things or something like that, like bunch of Democrats start ganging up, they start doing something. Bunch of Republicans start ganging up, they start doing something. They could change the whole stupid website. It starts making crazy things. Start putting fake things on there. But this, okay, let's talk about this a little bit because this is actually hopefully going to make sense. All right, or I know it'll make sense. But the idea is that I said sigma is unknown, right? So we can't really know really everything that's going on anymore, right? So these parts at the end here, they're what we call the tails of the distribution. Does that make sense? If you start going like this, and I say this is a normal distribution, and then I start saying like, okay, what if I made another distribution? But then it was like higher over here, so then it had to be lower over here because it still has to have area 1. And then it's higher over there also. Does that make sense? Does that make sense? Right, the area still has to be 1 though. Does that make sense? Then what does this mean? This means you're saying there's a higher probability for extreme values. Does that make sense? Does that make sense? And then like more usual values are less common. Right? Normal distribution would be saying like the stuff over here is more common, it's higher probability. Does that make sense? But then normal distribution would be saying over here is a lower probability. Is that correct? Right? But this stuff, if we imagine we're talking about like, let's say women's heights or something, right? And this is like women who are like 7 feet tall or something, right? All of a sudden we're saying now there's a better chance that there's a woman that's 7 feet tall. Does that make sense? More extreme values are possible. Does that make sense? Well, if you didn't know sigma, right? And you didn't understand what was going on with the distribution, you would start saying that more extreme values really should be possible. Is that correct? You can't even estimate how spread out the distribution is, right? Does that make sense? So if I can't say how spread out it is, I have to start saying that maybe there's a chance that the stuff over here happens more often than I would have usually thought. Is that correct? Does that make sense? So that's what we're doing here. We're just making this have a slightly higher probability over here. All right. Now, X bar though, automatically, when n is greater than 30, we know it'll follow a normal distribution. Does that make sense? So what I didn't pick the best one here, but they say this thing degrees of freedom is equal to n minus 1. So this V thing or whatever, which I think is pronounced new or whatever, this V is equal to n minus 1. So if V is 1, what is n? 2. And then this would be 3, and this would be like 6. Does that make sense? But then if this thing is infinity, this one would be infinity also. Does that make sense? Does that make sense? Well, he didn't write this one here. He should have written this one or whatever. But he should have written something here about 29 also. Okay? Or let's say 30, I'm sorry. 30. Because then this would be greater than 30. Does that make sense? All right. This one here though, this infinity one, will almost be identical to what the one will be with 30. Okay? Why? Because the thing is that when we pick V equals 1 here, we only sampled 2 things. Does that make sense? We're taking an average of 2 things. Is that right? You should be able to get really crazy things to happen. Is that right? You get 2 really, really, really heavy people. You get 2 really, really skinny people. You get 2 really, really tall people. You get 2 really, really short people. Does that make sense? It's possible. 30 though, harder. Does that make sense? A lot harder. Does that make sense? All right. So here, when you have 1 here, right? We're saying that there's still a pretty decent chance actually that you can get some crazy stuff to happen. Does that make sense? Then you start sampling 2 people, a little less chance, right? 5 people, a lot less chance actually. Does that make sense? And then this, which is sort of really like saying like just greater than 30. Does that make sense? This is actually a normal distribution. Does that make sense? The black curve is the normal distribution. Does that make sense? So as n increases, the t distribution turns into the normal distribution. Does that make sense? Once n is greater than 30, they're pretty much the same thing. Any question with that idea? Does that make sense, guys? I can't say opposite. They look very, very, very similar. They look very similar. No, most of the values are still in the middle. Look at this. What are you talking about? Look at how much area there is here and look at how much area there's over there. For this yellow thing. There's still a lot more area right here in the middle. The probability is higher here. Right? Just means there's still, but okay, but wait, but like if we look at this here, right? Like more chance, right? But like if we look here, right? This number right, I'm sorry, I don't know why I just zoomed in like that. This number right there, I'm trying to draw like the one right at the bottom for the black line. Does that make sense? I don't know what that is, but it's pretty damn small. Is that correct? And then if we go to like that one there for the yellow one, right? I don't know. That could be like 15 times higher. Does that make sense? Does that make sense? I can't really tell here, but that could be a lot of times higher. Does that make sense? Maybe more even. All right. Maybe 100. I honestly can't see how low it is. Does that make sense? That means this is saying there's 100 times more chance that that woman could be that tall. Does that make sense? So the point is you're really allowing for a lot more extreme values. Does that make sense? You understand? If you didn't know sigma, you would have to do that. Is that correct? Does that make sense? But it kind of makes it easy now. Every time you don't know sigma, you do t-distribution. Does that make sense? Why is this not working? The tail, we say if the probability of an extreme value is large, we say the tail is large. The tails are really just the parts at the end over here. The center, we don't say tip. We don't say tip. Doesn't make any sense. Like what if I start saying like it's like this? What if I say this? Then what? You got two tips? That's called bimodal. He talks about this. Bimodal. What are you saying?
No, I'm saying, look over here.
Center. It's okay. You can say it. Center. There you go. The wings, tails. Tails, center.
The bigger the probability, the bigger the tip. And you see how the black one has that big tip.
What the hell's tip? Center's higher. Why do you keep saying tip?
That's what it.
How about maximum? How about tip? This is the tip also, right? Oh, now they're the tails. Okay. All right. All right. Look, the area under the whole thing has to be 1. So if the part here gets higher, the parts over there have to get lower, right? That's all. Okay? Tip. I guess so.
And this is still normal.
No. No, this is called t-distribution. All right. So now this question here. Yeah, that's what I'm saying. Why you give everybody the crazy eyes? You huffed and puffed. I was kidding. So do one of the following. Find the critical value Z alpha 2. Find the critical value T alpha 2. State the T normal distribution applies. 98% N is 7. Sigma is 27. Population appears to be normally distributed. All right. So if the population is normally distributed, then we want to use normal distribution, right? But we can't unless we have sigma is equal to 20, unless we know what sigma is. But they're telling us what sigma is, right? So we already know what sigma is, so we're good. 98%, well, okay, so we draw 98% just like we did before. Does that make sense? Now they say find the critical value Z alpha over 2 or T alpha over 2, or state whether neither of these two things apply. Does that make sense? Well, they told me it's normal and they told me they know what sigma is. So normal distribution definitely applies. Does that make sense? So all I would need to do here is find out what this position is here. How do I find that? Z. In norm. 0.99 is correct because this would be 0.01 and this would be 0.01. Then you would just do 0.99. Does that make sense? Good. Does that make sense, guys? All right. Now, this one says n equals 10, sigma is unknown, population appears to be normally distributed. Now, again, we can only do any of this stuff if we think it's normal. Does that make sense? Sometimes you think it's normal and you know what sigma is. Then you can do Z. Does that make sense? Sometimes you think it's normal and sigma is unknown. Then you have to do T. Does that make sense? Every time you need to make a distinction between these two things. Does that make sense? Every question from now on, you have to make a distinction between it's saying, is it about a proportion? Is it about a mean? That's usually pretty easy if you just read the question. Does that make sense? But you always have to do this also. Does that make sense? So I'm always asking myself, is it a mean or is it a proportion? And then I'm asking myself also, is sigma known or is sigma unknown? Does that make sense? All right, well, this one they told us sigma's unknown, right? So that means I said that this is when we really use T. Does that make sense? So really, we draw the same type of picture. Just represent something that looks sort of like a normal distribution, because that's T looks like a normal distribution anyway. Is that right? Now it says 90%. All right, well, then this is 90%. Is that correct? Now, the only difference is that a T distribution does not only depend on mu and sigma or whatever, right? A T distribution depends on mu, the standard deviation, and this new thing called the degrees of freedom, which is just n minus 1. Does that make sense? But remember, the picture was changing based off of what the n was. Does that make sense? So we need to tell the calculator what the n is, so it'll tell us the right area or value. Does that make sense? All right, but it's very nice, actually, how this works. So all we do is we just go to distor here, right? And then you see now it says inv t. Does everybody see that? Does that make sense? Just like remember we were doing inv chi squared before. Does that make sense? We're using a t distribution. So we do inv t. Does that make sense? Inv t. What should I write for the area here? 0.95. Beyonce. That's my boy. All right. So then this one right here, right? No, but you got to do the area to the left. Is that correct? So we get 95er. Is that right? You see why I'm saying though? Just always remember to the left. It always wants to the left. Does that make sense? All right. What's DF in this case? Nope. 9. Just remember degrees of freedom is always the sample size minus 1. Does that make sense? All right. For a T distribution. By the way, this degrees of freedom thing changes depending on which distribution you're using. But we're only really going to talk about T. So all you have to really remember is just n minus 1. Does that make sense? All right. So the degrees of freedom is what? 10 minus 1. Is that right? Good. Of course, you could have just written 9, but I'm just reminding you that's what it is. All right. So I push paste, push this. Good. That's the answer. Does that make sense? So all I did was inv t, and then I typed in 0.95, and then I typed in 9. Does that make sense? And then it gave an answer of like 1.833 or something, I think. Okay. Does that make sense? Question with that? All right. Is that okay? All right, so now you're gonna actually see like the questions and like what the difference is between doing this and doing the other ones. But you're gonna see it's so freaking similar, it's not even funny. All right? Which should hopefully be good. Does that make sense? I'm just gonna show you how to do it on the calculator now because we only have 15 minutes or so. All right. But I think you're gonna like that better anyway. All right. So a sociologist develops a test to measure attitudes towards public transportation. 27 randomly selected subjects are given the test. Their mean score is 76.2 and their standard deviation is 21.4. Construct a 95% confidence interval for the mean score of all such subjects. Now, the thing is that I was mentioning previously, at the beginning, you have to decide if something is talking about mean or proportion, right? If it's mean, I need to be deciding between is it Z or is it T? How do I decide that again? What standard deviation? The population standard deviation specifically. Does that make sense? You gotta be careful with that, okay? So if sigma is known or given is correct, we do this. If sigma is unknown or we don't know what it is, we're gonna have to do T. Is that right? I didn't say anything about this when we do T, because we can always know what the standard deviation is for that thing, because it's just square root of P hat Q hat over N or whatever. Does that make sense? So it's never gonna be unknown. Does that make sense? Or, excuse me, we said here that what, N P hat and then N Q hat have to be greater than or equal to 5. Is that right? Does that make sense? Question? All right. So here, they're definitely talking about mean. Is that right? So I have to start deciding between Z or T. Is that right? How do I decide? What did we just say? How do we decide? Yeah. So the population standard deviation, if they give it to you, is that right? Then we can start calculating Z. Is that right? So Z, they gave it to me? Nope. Why is it not the population? Because it's really this word right here. There. Does that make sense? Because it's saying like they took these 27 people and then their standard deviation was this thing. Not everyone's standard deviation. Does that make sense? Does that make sense? So the word, you should know the damn word though. The word sample. Does that make sense? Right? These things are coming from the sample, not the population. Is that right? Yeah. But definitely we don't have the whole thing. Is that correct? But you got to read that. Does that make sense? That's literally the only reason why I put this question here to make sure that we talk about that. Does that make sense? All right. So then the but so easy to do this on the calculator. Okay. So again, all you do is just go in here, go down to these intervals. Which one do we have to pick? I haven't even told you which one to do. You should be able to tell me which one. Nope. Are we doing proportions? No, this is about mean. Is that correct? I told you last time, there's only 3 of them you have to know how to do. If it's not proportion, there's only 2 left. We just said it's not Z. We just said that we don't know the standard deviation. Is that correct? So it is t-interval. Does that make sense? You like that? So then no, but t-interval, whatever. Does that make sense? Right? So that should be easy. Is that correct? That should be really easy. Is that right? All right. So we get this. Data or statistics. Okay, we'll talk about what that means in 1 second. X bar. Oh wow, it tells you in the question. Standard deviation. Oh, it tells me in the question. N tells me in the question. Confidence level. They have to tell me, otherwise I can't tell them the right size confidence interval. Does that make sense? Should be easy. Does that make sense? Should be really easy, actually. No, you didn't click stats. Oh no, because you clicked test. You didn't click the right thing. All right, so we get this, and that's the answer. Does that make sense? Now the only difference is now the mean. This is a 95% confidence interval for the mean. The mean we think is going to be between these values. 67,734 and 84,666 or 666, excuse me. Does that make sense? Does that make sense? We're using the sample to construct this interval. Does that make sense? Where we think the mean might fall, right? 95% of such intervals will contain the true population parameter or mean. Does that make sense? Question with that? All right, now this one. They give you this, you should immediately know it has to be T. They did not provide me sigma. Does that make sense? This one's easy also. All you do is type in the numbers. Let it calculate everything for you. Well, hopefully you can type them in correctly though, unlike what I can do. Right? Does that make sense? All right, how do you think you're going to do this now? How am I going to construct the confidence interval? What do I click? So what do I click? Stat, test. So 8, right? Does that make sense? Now, we don't have statistics here. Is that right? We have data, right? Good. Does that make sense? But then it's like, where's your data, bro? Right? So then if you have to tell it the list, I think I just typed it in L4, I believe. Does that make sense? And then frequency, if there was a list of frequencies, we would type this in also. So this is just XI, FI again. Does that make sense? And then confidence level. And that's it. Does that make sense? Does that make sense? Does that make sense? Question? All right, let's do this one, 18. What's the difference between this one and the last couple? So how's that different? What's the difference between this one and the last couple? Say again? What do you mean? Telling you it's a sample. There's always a sample. Every single one of these things is a sample. We're trying to take the sample and then guess what the parameter is, right? Sorry? Is what a population? Is the sample a population? How does that make any sense? Either something's a sample or something's a population. What's population? I don't know what you mean. No. It says X bar. It says all random sample of 104 light bulbs. Are there only 104 light bulbs? It's definitely a sample, right? Plus it says X bar. What did we just say to do? Hmm? I don't know what you mean. They told us what the mean is right here. We're trying to find a confidence interval for the mean of the population, right? So we need to make a confidence interval. So how do we do it? What did we say to do? What was the first thing we said to do? I just wrote it down twice. Right here, twice. You have to see if you can use a normal distribution or if you have to use a t-distribution. Is that correct? So how do we know? Nope. First, you have to know if something is actually normally distributed or not. Does it even say here if it's normally distributed? It doesn't, does it? Does that make sense? Is that a problem? Sometimes. So really, the first question you need to ask yourself always is it normal? Does that make sense? Then it's either yes or no. If the answer is no, we're pretty much screwed. Does that make sense? Because we haven't really talked about that at all. Does that make sense? So this, all we're going to be able to say is like this particular type of thing doesn't apply. Does that make sense? The average is our guess. We guess this is the answer. Does that make sense? But if it is normal, then we have to really start asking ourselves, is it going to be mean or is it proportion? Then if it's mean, we need to ask ourselves, is it Z or is it T? In this case, we always do Z as long as NP hat and NQ hat are greater than or equal to 5. Is that correct? How can we say if something is normal, though? We can use the central limit theorem. The central limit theorem said that X bar is automatically normal with mean mu and standard deviation sigma over square root of n when they're independently selected and n is larger than 30. Does that make sense? Does that make sense? Well, guess what? That's way larger than 30. Does that make sense? Does that make sense? So n equals 104 is larger than 30 means X bar is normal. Does that make sense? Does that make sense? Do you see why important the central limit theorem is? Because then anytime you start sampling something larger than 30, the average starts becoming normal. You can start saying what the shape would be. I just pretty much said if it's not normal, it's much more complicated. Does that make sense? So this X bar is normal, right? And then we even know the standard deviation here. Is that correct? Sorry? No, that's just from the theorem. All right, you just have to check if it's bigger than 30. So I'm just saying this is bigger than 30. No, I'm just looking at this and just saying it's bigger than 30. We have to check if it's bigger or smaller. If it was smaller than 30, I can't do this. Unless they say it's normal. Either they have to say it or it has to be larger than 30. Does that make sense? Does that make sense? All right. So then but really there's only one small difference here. All you do is go in here, right? And what do I do? Which one should I pick? Z, because we have sigma now. And then the calculator really should convince you even more. Because when you click this, it starts saying sigma. Does that make sense? It should remind you you need it. Does that make sense? Z interval, yep. No, you're just clicking test. You need to click interval. Scroll down. Everything saves always. Just delete it. Push clear. Are you talking about the list? No, it's impossible. It just means you're not typing it correctly. It's impossible. So you get this? Mm-hmm. Does that make sense, guys? So literally all you have to do is be looking for whether it provides you sigma or not. Does that make sense? And I guess that's all. All right. So that's really the end of all of the confidence intervals now. Does that make sense? So all we have left now is hypothesis testing. Okay.